The 30th element on the periodic table is known as zinc. This is Norris Teaches Science with me, Mr. Norris. This is Physical Science Edition video. Today we're going to talk about momentum. So your goal for this video is that I can calculate the momentum of an object based off frame of reference. So what is momentum? Momentum is the product of the mass of the object and its speed. So we're going to talk about the amount of matter in it times multiplying it by how fast it's going. Now, in a sense, for momentum, the heavier an object, the harder it is to stop its movement. If anyone has ever, played football, or watched football, this is one of the reasons why you have those big guys protecting the quarterback, because they're harder to move because of their weight or their mass. So the momentum formula, algebraically, momentum equals mass times velocity, or lowercase p equals lowercase m times lowercase v. Lowercase p represents momentum, and its unit is kilograms times meters per second. M is equal to mass. Its unit will be kilograms, so the mass will have to be in kilograms. And velocity is going to be in the unit of meters per second. Now, this is algebraically. Remember, I like to place it in the triangle form. So little p at the top, m and v at the bottom. Reason why is because you're multiplying numbers, multiplying mass and volume, and the numbers have to be next to each other for them to be multiplied. So let's look at this first example. It says, at the end of a race, a sprinter with a mass of 80 kilograms has a speed of 10 meters per second. What is the sprinter's momentum? So what are you trying to find in here? Well, you're trying to find the sprinter's momentum. And so we're going to place the letter in the triangle that represents momentum. The letter is P, lowercase p, and so that goes at the top. At the bottom, we're going to have our mass, which is 80 kilograms, and we're also going to have our velocity, which is 10 meters per second. Now, the numbers are next to each other, so we're going to multiply. 880 times 10 is going to be 800. Right? But you still need to give a unit, and it's kilograms times meters over seconds. All right? And that is the momentum of this sprinter at the end of the race. All right, here's problem number 2. I want you to pause it real quick and try to use the formula on your own. I'm going to count to 5, and then I will begin going over it. But I suggest you guys try it on your own. 5, 4, 3, 2, 1. Here we go. It says a pitcher throws a baseball with a speed of 40 meters per second. The baseball has a mass of 0.15 kilograms. What is the momentum of the baseball? So what are we trying to find? All right, we're trying to find momentum. So that means the P at the top. The P stays at the top. In the bottom, we're going to have our mass, which is 0.15. And we're going to have our velocity up here too. Now we're going to take our calculator out, and we are going to do 0.15, and we're going to multiply it by 40 because they're next to each other. Remember, numbers next to each other you multiply. If they're on top of each other, you divide. When you do that, you get your answer to be 6. And then we have our unit, kilograms times meters over seconds. And that is the momentum of the baseball. Just as a side note, I'm a big baseball fan. Hopefully, if you haven't noticed from my pictures up here on the PowerPoints, I am a Tampa Bay Rays fan. So go Rays. But let's do one last thing about momentum. It's very important. A slow moving massive object and a fast moving small mass object can have the same momentum. You just have to have the right speed and calculation. But that's a little bit about momentum and how it fits in with physics and the physical science part of your learning. I hope you learned something today. And like always, I'm Mr. Norris, and I am out for this video. See you at the next one.